Good morning and welcome everyone. First off, let me introduce myself. I'm Dave Chin, sponsor and director for the NEXTOR program. And in my spare time, I serve as the director of performance analysis in air traffic. It's truly great to see so many familiar faces and meet new ones. Today is a special day in that it marks an early celebration of the 20th anniversary of NEXTOR, the FAA Center for Excellence in Aviation Operations Research. NEXTOR was established in 1996, and over the years, it has produced many analyses that have helped the FAA make more informative decisions, shape policy, and take more effective actions. NEXTOR has grown and evolved over time. 5 years ago, I challenged the NEXTOR universities to expand their sphere of influence by sharing their research and knowledge on the global stage. So one might ask, how well did they meet this challenge? One measure of success recently showed up in a NEXTOR organized workshop entitled Global Challenges to Improve Air Navigation Performance this past February. Presenters from around the world, from places like Switzerland, New Zealand, China, Germany, Belgium, France, and Canada, representing ANSPs, airlines, and international organizations, paid their own way to attend. Our NEXTOR universities have clearly demonstrated that they have world-class recognition and a big draw. Today, you will hear briefings on diverse topics that I hope you will find stimulating, entertaining, and provocative in some cases. As you can see from the agenda, we have a full day ahead. Now, Mr. Administrator, I want to point out that these professors paid their own way to come share their research with us. With the budget outlook the way it is, I told them that they would be celebrating NEXTOR's 20th anniversary at a special FAA LCC. So we all know what FA stands for, all right? LCC, Low Cost Conference. And this is where you're sitting. So with that said, it gives me great pleasure to invite the FAA Administrator, Mr. Michael Vuata, to deliver the opening remarks. Michael?
Well, David, thank you very much. I am really happy to be here with all of you. And I certainly appreciate this emphasis on doing things in a cost-effective way. And NEXTOR is certainly a great value for us. I think those of you that know me know I'm a bit of a history buff. And what I always like to think about is what's been happening in the past and to tie it to what we're doing today. Well, around 70 years ago, the great American writer James Thurber, who we've all heard of, was known for writing short stories and drawing a lot of cartoons that were commentaries over his life. And he said something that has really passed the test of time. He said, it's better to know some of the questions than to know all of the answers. That's certainly the case for me. And I think that he is on to something, and I think that I'm one that asks a lot of questions and am very short on the answers, and that's really what we look to organizations and institutions such as yours about. There's a satisfaction that comes from this process that we call inquiry, and certainly U.S. scholars know that very, very well. If the world had all the answers, then we would have nothing to strive for. It would be pretty boring. And if we kid ourselves into thinking that we have all the answers, then we're just being complacent, which in aviation is something that none of us can afford. So it's been 20 years, and the NEXTOR universities have been invaluable in helping us to answer key research questions that are before us in aviation. Started out as a group of 4, now it's doubled to 8 universities that are participants in this. And today, there's going to be some great work presented on aviation safety, on ADS-B, performance modeling and analysis, and air traffic flow management. Now, NEXTOR research brings a level of objectivity and proof that helps guide us at the FAA in making the investment decisions that we need to make, as well as our larger strategic efforts. This work is especially important as we work on our own agency strategic initiatives that really place a premium on the use of data and analysis to set priorities. I'd like to touch briefly on these initiatives. We've come a long way in safety. We have a system that is unbelievably safe, and that is largely as a result of great work that has been done across the industry. But we all know that safety is often been accomplished in the past by studying accidents, and we also know that we're not having a lot of accidents now. But that's not to say that there isn't risk in the system, and it's a question of how do we analyze that risk, how do we collect data, how do we identify areas that pose the highest levels of risk, and then how do we direct resources toward addressing that risk. And that results in an aviation system that's not only safer, but it's smarter because it's relying on data. We're focusing on delivering benefits to the aviation community through technology and through infrastructure, and we're also focused on how we integrate new users into our national airspace system, and I'm going to talk a little bit more about that. And we're committed to enhancing our global leadership by using data to determine where we should focus our international efforts. And all of this is taking place against the backdrop of a big change we're going through as an agency and as an industry, where we're recruiting and developing a highly skilled workforce that thinks differently about how we address the demands that aviation is going to place on us in the future. Now, we recognize that aviation is becoming increasingly complex and increasingly globalized. We have to be more nimble in addressing the challenges while still meeting the industry's rapidly changing needs in, as you heard, a very budget-constrained environment that we're all dealing with in government. So this is where you come in. I know I can lean on you to help us achieve those objectives, and I'm confident of this because NEXTOR has a great track record of accomplishment over the last 20 years. You provided us with safety analysis that demonstrated the need for the ASDX program, which has helped ensure runway safety at our nation's busiest airports. We're now building off this deployment to provide surface visualization tools at some of our terminal approach facilities so that controllers can get a better picture of what is happening on the airport surface of ASDX-equipped airports. Now, this is helping us use airspace much more efficiently. You also provided important operational research for ADS-B, dating all the way back to the earliest days of the program with the Capstone program in Alaska. These early studies gave us some tremendous insights into the benefits of providing pilots with traffic and weather data in the cockpit, and we're well on our way toward meeting our goal of completing the transition to ADS-B by 2020. NEXTOR also conducts the Total Delay Impact Study, a product that quantifies the total cost of delays in the airspace for stakeholders and for society in general. The information of this study has been cited very widely in other industry papers as well as in congressional testimony, and you might have seen it in my testimony recently. In addition, NEXTOR is continuing its research on wake vortices. These studies have the potential to expand capacity by helping us safely reduce wake separation standards around the country. Just look at the recent success we've had in Atlanta, where we've increased our arrival rate at Hartsfield-Jackson International Airport by about 5 flights an hour at the nation's busiest airport. And your research has really been essential in enabling us to do that. And lastly, let me note that NEXTOR recently completed a report that details how better predicting flight time could reduce airline operating costs. And that research is going to be presented later on today. So these are just a few examples of the contributions that you've made. These efforts are helping us make aviation much more efficient, much greener, and at the same time ensuring that we maintain the highest levels of safety that the public expects from our aviation system. Now, we can all take a lot of pride in these past accomplishments, but as Thurber suggested, there's a danger in thinking we now have all the answers. With progress comes a whole new set of questions that we need to be thinking about in the years ahead. So what do we research next? Well, we can certainly benefit from continuing research in support of our next-gen activities, particularly the priority areas we've identified in the near term. These include expanding the use of performance-based navigation, improving surface operations at airports, making multiple runway operations more efficient, particularly at space-constrained, closely spaced runways, and implementing data communications. Perhaps NEXTOR can help us capture and better understand the benefits of NextGen. In doing so, you can help us persuade airspace users about the value of investing in next-gen avionics. And perhaps you can help us see how the innovations we're implementing today can be enhanced to provide even more benefits in the years ahead. Earlier this year, the FAA proposed rules permitting the use of small unmanned aircraft, those that weigh less than 55 pounds, for non-recreational purposes. Now, the proposed rule would allow those aircraft to operate during daylight as long as the operator maintains visual line of sight and meets a few other requirements. The rule has been, for the most part, widely received as representing an appropriate balance, but we did receive more than 4,000 public comments on the proposal, and we're working to address each of those before we finalize the rule. This, however, takes time, so we're actively looking for other ways to expand the use of unmanned aircraft in the meantime. We're receiving valuable information from our 6 national test sites, including our Virginia Tech site, NEXTOR University. We're also accommodating requests for some commercial operations, and this month we announced 2 additional steps: the Pathfinder program and the Unmanned Aircraft Center of Excellence. With the Pathfinder program, we're partnering with industry. In this case, Cable News Network, or CNN, the BNSF Railroad, and Precision Hawk, all of who committed extensive resources to perform research that will help us determine if and how we can safely expand unmanned aircraft operations here in the United States. The Center of Excellence is a world-class cost-sharing public-private partnership between 15 of the nation's leading unmanned aircraft and aviation universities that have already proven their commitment to this research. And it will focus on research, education, and training in areas critical to safely and successfully integrating these aircraft into the airspace system. And we're also working to safely integrate the growing commercial space industry. We're looking to reduce the amount of airspace that must be blocked to support launch and re-entry of commercial space launches. And this is an area that is growing exponentially here in the United States. We're also studying how to more efficiently release that airspace to reduce delays incurred by traditional airspace users that are otherwise rerouted miles out of their way. Now, perhaps your research can help us safely and efficiently address how we do that and get us closer to true integration of these activities in our national airspace system. Aviation has always moved forward because it's been founded on 2 basic principles here in the United States. It's always been founded on how do we harness innovation and leverage that innovation for the benefit of the public, and how do we collaborate? How can we work together across the industry, government, academia, and industry in order to ensure that our aviation system can be the best it can possibly be? We've driven down safety risk to an exceedingly low level, but we know that we have to drive it down still further. We're delivering benefits through NextGen, but how can we build on that progress and accelerate the growth and deliver even greater benefits? We're a global leader in aviation, but how do we enhance that leadership role even more? Now, as we continue to answer all of these questions, others will pop up, and that's just what we need. And through this process, we'll positively shape what the future of aviation is going to look like in the years ahead. It's been a great 20-year run, and I can't tell you how much we appreciate the work that you are doing to help us shape what aviation is going to look like in the years ahead. Thank you very much for your contribution.
Well, it's great to be here, and I very much appreciated the administrator's remarks. You look up here, and as Dave said, next year will be NEXTOR's 20th anniversary, and that's pretty sort of daunting when I think about it, and the others of us that have been here for that entire period, and we will have a celebration. Very low cost, of course, but we will have a celebration next year. Before I start, I want to thank Dave Chin for organizing this event, and very much appreciate Dave's dedication to NEXTOR, as well as the previous program managers for NEXTOR, and I think it shows a great belief on his part, but also just generally the FAA administration's part, and as you could very definitely see from the administrator, belief in research, the value of research, and also data-driven decision-making. And I think that's what NEXTOR is all about, and we very much appreciate the FAA's focus on that, and and that's obviously, we very strongly believe in that, and very much appreciate that point of view as well. All right, so what I want to do is give a kind of a history of NEXTOR over the years, so here's just a little outline of my presentation. I'll just talk about the kind of vision and strategic goals, a little bit of the history. Then I want to go through a number of our kind of research projects to try to give you what I think are, it sort of gives the tenor of NEXTOR, the things we've accomplished, and kind of where we're going. And then talk about some of our other activities, and probably most importantly about the human capital we've produced, the great graduates we've produced. Okay, so the vision, so it's to be leaders in the aviation community, and I think there's three aspects. One is to advance knowledge, that's our research. The second is to convey that knowledge to industry, government, et cetera. And then third, the training and education of aviation professionals. So those are kind of the three main purposes that we exist for, and that we're all dedicated to. This was originally a Center of Excellence in Aviation Operations Research, but as you'll see as I go through the various things we've done, we've sort of interpreted that quite broadly, and we've really done a number of research in a very large number of areas of great interest to the aviation community and the FAA. Okay, so just a very brief history. So it was founded in 1996 as an FAA Center of Excellence, part of the Center of Excellence program here, based on a competitive bid process. Initially, there were 4 core universities: Maryland, MIT, UC Berkeley, and Virginia Tech, and we had several industry partners and affiliate universities. George Mason was added as a 5th core university in 2002, and then there was a recompetition in 2011, as part of that recompetition, we added 3 new members to our team: Georgia Tech, Ohio State, and Purdue. So at this point, we have 8 core universities. I think one interesting or one important aspect of NEXTOR, and I should say that I can't remember what the program was. We had some meetings with DOT about doing some joint work with them, and one thing that they really appreciated was this next to last bullet I have here, is that we have no guaranteed funding. So we've never had sort of a pot of money. We say, what are we going to do with this money? Rather, we work for various program offices in the FAA. I like to think of NEXTOR as a relationship. We have a relationship to the FAA where if there's a need for research, we can easily negotiate a research project with the FAA. However, we have to deliver. We have to work with that program manager to deliver the goods, or we don't get any additional funding. And so I think because of that, we've very much focused on working, well, first of all, finding out what the FAA needs are, working closely with various program offices, and of course, doing the best job we can do. I should also say that over the years, we've worked with industry in a variety of roles, and our industry partner program has evolved in different ways. And also of note is that we've had substantial recent funding from NASA. Okay, here's the team. I'm not going to list all the names there. Probably the most important thing to point out is the diversity of faculty. And so it was the Center of Excellence in Aviation Operations Research. So a number of our faculty, including myself, claim operations research as their primary discipline. However, we also have a number of faculty in transportation engineering. These are usually in civil engineering departments. We have a number of faculty in aeronautical engineering. And we have a number of faculty in transportation economics. You know, in addition, we've worked with faculty in both electrical engineering and economics. So I think it's this huge breadth of the faculty involved that's allowed us to tackle a very broad section of problems and bring a very certainly cross-disciplinary and innovative take on the different problems that we've tackled. Okay, here's a list, and this is probably a partial list of our industry partners and industry collaborators. And you know, we've worked with industry in a wide range of ways. You know, sometimes very closely as joint research, parts of joint research teams. Sometimes we will do a sort of the more basic research, and then we'd collaborate with industry to sort of take the next step and implement it in practice. So we've collaborated with these industry partners in a wide range of ways, but I think that's enriched our research, but also helped us, you know, transition this research into practice. And here you'll see below also the list of affiliate universities who also, so affiliate universities also can do projects, however the sort of core governance is through the core universities. Here's just a list of the major research project areas: air traffic flow management, economics and policy, safety, metrics and data analysis, and benefits analysis. So what I'd like to do is first start with talk about 6 early impactful projects. And I say early, some of these are still, they're just long-term research areas, maybe not so much individual projects, but I think this will give you a flavor for the wide variety of things we've done, and also some of the advantages, if you will, of that NEXTOR brings to the table. So since I'm giving this talk, I will start with collaborative decision making, which is kind of the project I've been most involved with over the years. And if you know the history of collaborative decision making, the whole activity at the FAA kind of started about the same time that NEXTOR started. So in the mid-90s, NEXTOR started in 1996. I think the initial efforts in collaborative decision making started right before that, 94, 95. The first implementation for ground delay programs was 1998. So from the very beginning, this was a major research focus area of NEXTOR, and we pretty much continuously have had projects in traffic flow management with an emphasis on collaborative decision making continuously over the years. And by working closely with the industry partner Metron Aviation, we were able to transition a number of our research ideas into practice, into decision support tools used by the FAA and the airlines. I should also say that to me personally, this was a kind of a very interesting area because it just gave a whole new focus on resource allocation, optimization, et cetera. And among other things, it was an opportunity in which equity or fairness was a big piece of this, and I think it got to us thinking about how do you quantify equity and fairness, how do you integrate that into decision models, and some of the research we did in in this aviation context was taken further by other researchers and applied in a much broader set of context beyond aviation. The second project I wish to talk about is positive passenger bag matching. And this, again, was a very early project, and some of you may remember this. So it was at a time when the Congress was trying to decide whether to require positive passenger bag matching on U.S. domestic flights, and that would mean that if a bag was on a flight, then the passenger who owned that bag had to be on that flight. And at that time, the airlines were basically saying that this would be very, very expensive, and you know, very much resisting this new regulation. So NEXTOR undertook a study, and it was a kind of a broad study in the sense that it involved fast time simulations, but also actual working with airlines. And I think Arnie Barnett was, you know, driving on baggage carts and things like that as they monitored carefully that the airlines actually did. We actually did controlled experiments, you know, with the airlines to understand what the actual costs were. And in fact, the results showed that the costs were not that great. And in fact, you know, eventually a law was passed. And I think this shows a couple of things. One is the ability to design very complicated experiments of this type, you know, involving computer simulation, but also, you know, working with, you know, actual operational tests, but also our objectivity, because I think we got an answer that a lot of people didn't like, and, you know, to be honest, there was a lot of resistance to what we're trying to do, but we, you know, we were a very objective force in this case, and I think, you know, really showed through data-driven decision-making what the right answer was. This is actually a more recent project that the administrator mentioned, the Total Delay Impact Study, and this quantified for the year 2007 the total economic impact of air transportation delays to society. And I think this was noteworthy in a couple of ways. Probably the most important is, or probably first of all, there's been a lot, you say, well, a lot of people have thrown numbers around, but I think we applied a very careful scientific approach to the study of this problem. And moreover, I think we developed some very innovative ideas and notions along the way. And for example, there was some very innovative work done on passenger delay and the difference between passenger delay statistics and flight delay statistics. And in fact, Professor Cindy Barnard will talk about kind of the continuation of that work this afternoon. And I think there was a lot of other innovative things done in this project in terms of not only quantifying the delays, but understanding cost mechanisms and you know, what sort of how delays and related things do actually impact cost and society. Well, this is kind of a continuation of, you know, the passenger delay work I just mentioned was integrated into the Total Delay Impact Study, but this has been a project that has gone on over the years, and as I mentioned previously, an important aspect of this is the difference between passenger delay statistics and flight delay statistics, and I think this really opened some people's eyes to understanding the implications, and among other things, understanding that, you know, you can't just measure performance of the system by flight delays. Things like flight cancellations and other aspects are very important too when you put them all together to really say what is the impact on passengers. Another project, and this airport congestion management project, and this was very much in the policy domain. And so this project was motivated by the expiration of the high density rule at the New York area airports, and very specifically at LaGuardia Airport. And so the idea was to say, what should be done after the high density rule expires? And we undertook, and among other things, the notion of use of market-based mechanisms was to be examined. So part of this project, we had 2 strategic simulations, and what I mean by that is, they're sort of mimicked after the kind of wargaming exercises that DoD holds, and in particular, we brought in all the stakeholders, so airport operators, airlines, FAA decision makers, in kind of a high-stress environment to try out things like different ways of, like congestion pricing, slot auctions, but also other kinds of administrative measures, and then showing how, they would impact the system under, various scenarios, and, to getting the different actors to really interact in sort of very realistic ways. And as a result of that, we generated a toolbox for government policymakers that allowed the selection of different components for congestion management alternatives. And there were a number of proposed rulemakings and actual rulemakings that were produced as a result of that. Also, shortly after that, there was something called the New York Area Rulemaking Committee established, and we played a role in their deliberations as well. So the final one I want to mention, and this will be the subject matter of our first presentation after this, and that's the fatality risk of air travel. And this is, everything else is the work of many faculty and many schools. This is only one faculty and one person, Arnie Barnett. So actually, he's had a little bit of help, I guess. But over a long period of time, he has sort of analyzed the fatality risk of air travel and performed periodic updates upon this. And the related analysis used to estimate the impact of various FAA programs on improving safety, understanding the variation in safety risk across regions, and also estimating the benefit of programs and technologies. So this research has had many side benefits, and it sort of had impact in a lot of different ways. Okay, so that's kind of a history of some of the older projects, if you will, although some are more recent and some are still ongoing. I just want to now mention some of our more recent projects. So, and the administrator mentioned this, we've done work actually for a long time on ADS-B rollout, things like determining which ADS-B applications have most value to different user groups, developed high-value traffic simulation awareness and alerting application, and cost-benefit analysis of ADS-B's use for oceanic traffic. And this will be the subject matter of the second session in the morning. Obviously, this is a very important issue today, and a very fundamental piece of NextGen. I'll mention this work, although I have to give credit to Dave Chen and John Goulding and actually their Eurocontrol counterparts, because a lot of this work actually was done at the FAA, but we did play some role in it, and I just want to, I think this work has had a huge impact on both sides of the Atlantic, people thinking about the U.S. and European air systems, and this work has compared the two systems relative to delay, throughput, and other dimensions, and it's really kind of opened everyone's eyes. When you see a difference, then you say, well, what caused that difference? And can can Europe should Europe do things differently? Should the U.S. do things differently? Are there areas for improvement, et cetera? And I think this this work has really been very, very influential in setting new research agendas, and has kind of opened eyes on both sides of the Atlantic as to how can we change our systems and improve our systems. I mentioned that we had a number of NASA-funded projects, and in fact, this is kind of a laundry list of several of them, many of them related to next-gen ideas. The first one there is sort of looking at stochastic models for managing air traffic in the context of, again, looking at next-gen. The second project there tried to understand what is the benefit of reducing variability in the system, and so develop models for how variability cues would change as some of the next-gen technologies were implemented, and to say what is the impact of that. And you can see a number of others of these NASA-funded projects that all address next-gen issues. I mentioned one project at the bottom of there on best, this is an FAA project on the use of best equipped, best served, and implementing that in the context of ground delay programs. The administrator also mentioned our work on wake vortex modeling. I think this work is also very important. Analyze and evaluate alternate wake separation concepts, looked at existing models and development of new simulations as appropriate. And one big aspect of this has been an estimation of the potential benefit pool, and also how the changes in wake vortex methodologies fit into the broader next-gen context. This is just as kind of a list of others. I won't go into these in any detail, but just the ones on the left are things that are going to be discussed today. And as I said, some of these are sort of projects that have been ongoing for years, and some of them are more recent projects. But the ones on the left are kind of it's kind of an outline of the talks that you're going to hear throughout the rest of the day. All right, so that's kind of a little laundry list of our past and current research. I'd like to talk about some of our other contributions. So as I said, another aspect of NEXTOR is to convey our knowledge to the community, and we've done this through seminars, workshops, and short courses. So I'll just give you a little bit of an overview of this, perhaps a quick overview. So first of all, kind of leading up to the work I mentioned on congestion management for LaGuardia, we held a series of economics and aviation policy workshops, the first one at the University of Maryland, and the next three over on the Eastern Shore. And we brought together airline executives, FAA executives, and also a number of economists, both from aviation economics and other economists. And in fact, at one of these, we had a Nobel Prize winner. He had not won the Nobel Prize yet, but he did a couple, I guess after attending that workshop, that helped him. But anyway, and these were a little bit patterned after some of the workshops that the FCC held in advance of their spectrum auctions. But I think they were, very frank discussions about congestion management, economics of it, and a wide range of those issues. And a lot of that thinking informed some of, the eventual policy decisions and rulemakings that the FAA took in, proceeded with in the coming years. A second set of workshops are National Airspace System Performance Workshops. These are held at the Silmar Conference Center in Pacific Grove, California. They've brought together FAA executives and analysts and industry and researchers, and they generally are focused on performance, system performance issues. And I think Dave mentioned the most recent one we had this year. We had a global focus, so we brought together air transportation professionals from around the world, and it really kind of focused on what are the differences in aviation system performance around the world and the way these different systems operated. So these have had a nice flavor of research, but also current issues and topics. So we think global issues are a current topic right now. I think an earlier one, for example, was when there was kind of the system delays were going up, but the traffic was going down, and and people kind of believed that, and the focus was kind of on the New York area airports. So it's kind of a focus on New York area airports. To what degree are they really causing problems across the entire NAS? And to try to understand how traffic could be going down, but delays going up. And it just gives you a flavor that we did focus these on sort of current issues, but also brought in long-standing research to think about them. Just a couple comments on others. So we've had workshops on infrastructure management, air traffic management, a number of short courses on things like air transportation systems analysis, infrastructure management. We even had one on equity and fairness in air traffic management, et cetera. And I should mention that pretty much continuously from the early days of NEXTOR, UC Berkeley has had a short course on airport planning. They even invited me to give the dinner speech there once, but that was only one time. I don't know why, but that's Okay, finally I'd like to talk about our NEXTOR students, and in many ways this probably is kind of our greatest legacy. And I should say, maybe give you a little bit of a personal point of view. When prior to the start of NEXTOR, I had worked, in fact, I started working in telecommunications before NEXTOR was founded way back. But then I moved into more transportation, routing and scheduling, but kind of surface transportation issues. And I started to do a little work in air traffic management. And then I was part of the team that bid on the NEXTOR project. But really, the founding of NEXTOR totally shifted my personal research focus to the extent that, I'd say 80% of my research focus was on air transportation, air traffic management after the founding of NEXTOR. I should also say that if you look at where our students have come from, some of us have strong aviation programs, so we get students from those aviation programs, and you say, well, those are students who would go into aviation anyway. But on the other hand, a number of the students come from other disciplines like applied math, the business school, electrical engineering, et cetera. And in fact, I think that's particularly true at Maryland. We have a transportation engineering program, but we don't have a particular strong focus on aviation. But we have a lot of students from economics, applied math, et cetera, and those students have now taken up careers in aviation. And I think without NEXTOR, that certainly would not have happened. So in that sense, it's really had a very significant impact on the sort of next generation of aviation professionals. So, this is my own quote, perhaps the greatest legacy of NEXTOR is not the impact of its research projects, but rather the large cadre of students it has trained who are quickly becoming the next generation of thought leaders in air transportation. And, one thing about, it's not like these students, they go to classes and learn things in classes, and of course they do go to classes, but I think the thing about their training is they work closely with faculty on research projects. And that's about as good a training as you can get. And it's FAA projects. So these are students who are very, you know, they get, in some sense, the best training you can imagine to work on aviation projects in the future. And over the 19-year history, NEXTOR universities have awarded more than 104 PhDs and 138 master's degrees to students involved in NEXTOR research projects. And this is just partial. These are lower bounds because we've kind of lost count a little bit. I was trying to, we're going to try to get a more accurate count, but there's more than that. All right, so what are these students doing? Well, a number of them have taken faculty positions at several prestigious universities. So, you know, they are now, they're leading some of our, research projects, FAA research projects and NASA research projects. And so, you know, these are truly becoming and have become some of the new thought leaders in aviation. Secondly, the employers of NEXTOR PhD and master students span the entire range of aviation community, including here at the FAA. Several have gone to work for the FAA. A number have gone to work for airlines. And then the very familiar names of the community that does a lot of the research and development work for the FAA and for other institutions and for airlines, also a number of airport consultants. And then, of course, other government agencies, including NASA, DOT, Eurocontrol, and airframe manufacturers. So I think, as you can see, the students have kind of really, you know, permeated the aviation industry and really, you know, I think have had a significant impact and are becoming and have become and are becoming the new leaders in the industry. So we and our former students look forward to the next 19+ years. Thank you.